log in from desktop if you can, because shortly after the quick session on passwords, we'll have a fun CTF challenge for you to try these skills out yourself. So highly recommend you to join from the desktop if you can. We will, okay, cool. So we've started the recording, cool. All right, we can get started then. Cool, so I am Tanishq Chaudhary from the Hacking Club, and in this meet, we'll talk about passwords. And the story of passwords starts from Rockyou.txt. Okay, so Rockyou was a company that started around in 2005, and it used to develop widgets for Facebook and MySpace. MySpace, by the way, is just Facebook for boomer people. And it used to do that. However, in 2009, it suffered a massive password breach. It was one of the biggest ones at that point of time. In fact, the password breach was such a stupid mistake by the developers that it was a 10-year-old SQL injection vulnerability. From 2009, 10 years before that, the vulnerability was found, and still the developers did not fix it. And hackers, just by using this 10-year-old exploit, were able to gain access to the database. In fact, as it turned around, the database itself was unencrypted, which means that you could just look at the data as is. There was no layers of security. If you had the access to the database, you have the access to all of the passwords stored in plain text. And what it means is you have a huge list of users, a huge list of emails and passwords available in plain text for you to see. Now, here's what the hackers did. All right, all the passwords are stolen. By the way, there were around 32 million passwords that got stolen for the 2009 password breach. Now, here's what the hacker did. Okay, the hacker did not ask for any money, which is usually the case. They'll hold the company and they'll say, give us money or we'll release the data out. Some hackers also try to sell this information out to the dark web, which is also something we'll explore in later meets in the Hacking Club. But for now, the hacker didn't even choose to sell this information. What the hacker simply did was upload a file called rockyou.txt on the internet out for everyone to see. That file, by the way, is one of the biggest collection of passwords ever. In fact, here's a sample. I'll provide the links down below. And here's a sample for all of the passwords that people used on that website. Remember, the database was unencrypted. There was no layer of security. Once the hacker got into the database, he could see all of the passwords written out. And so you can see people with some good, some bad passwords here and there. But everything was out in the open. All right. So passwords, yeah, important to know. All right, so how do we store passwords? When it comes to passwords, take for example this case. When you type in your email ID and passwords for Google authentication, it sends over the data to servers somewhere in USA or India or wherever, and it uses some hardware on top of it, some software on top of it to manage the data. Very simple. Now, one way you can store the passwords is just using plain text. That is, this is our club email ID for Google. And Google could store the passwords this way, saying that, you know what, if you can look at the database, you can immediately look at the password. But as we saw before, this is not a good idea. Storing passwords in plain text is even more obvious that what is the password is. And here's another example for like how just the passwords can work. But can we do something better? Can we store the passwords in such a way that it is hidden, that it isn't exactly obvious what the text is supposed to mean? When I write password as the title over here and password 1 2 3 4 is not strong, you can immediately know that this is a password. But can we do something to hide it? Can we do something that makes the password less visible? Well, one of the things that you can do is encode the passwords. And below are three common encoding schemes, which uses base 16, 32, or 64. Now, we won't go into too much detail about the theory of how these base 16 or 32 or 64 encodings work, but these are a very common way to store the passwords. At least they were a common way to store the passwords. The thing is, you can see that password, if you store and convert it and pass it through a base 16 encoding, it'll look something of this sort. Now, if you look at this number, there are a bunch of letters, a bunch of characters, and a bunch of numbers. You can't really tell this is a password just by looking at this. In fact, in base 32, it's even more less obvious. Like you can't look at this and say it's a password. Similarly for base 64. These three encodings are, by the way, very important, and will have a CTF challenge at the end, which has some sort of element for all of these three. Anyways, encodings is one way to store the passwords, but there's something wrong. See, for encodings, it's easy to go both the directions. Just like how we went from password and we used base 16 encoding to create this string, it's very easy to look at this string. And even if you don't know if it's a password or not, you can pass this string back into this base 60 encoder. And this time you'll basically decode the string and you'll get the word password back. So what's going on? Well, if you notice, even in this case, you have password, you pass it through the base 32 encoding, and you get this string. Now, again, you don't know what this string is, but if you just try to pass it through a base 16 or a base 32 or base 64 filter, maybe you can get something out of it, right? So this encoding is going both the directions, which means that it is not very good for security, especially when it comes to knowing that, just like how I described these three encodings to you, hackers also know this very well. And these are the first three things that we'll try to do. Base 64 is one of the most famous encodings used by hackers all the time. It's super powerful, and we'll again describe this in much more detail in later on meets. It's super helpful. In any case, encodings does not look to be a good idea because you can go both the directions. So what if we have a function that goes only one direction? Is there a possibility for a one-way function? Okay, let's talk about hashing. Hashing is the simple idea that you will take a word, in this case it's a password, and you will pass it through some function that can create this large string, which isn't exactly obvious what it is. But the thing is, you can go one way very easily, but you can't go the other way easily. Going one way is easier, and going the other way is much harder. These hashing algorithms are designed to be one-way functions. Now, of course, they have a lot more properties, and you can go into the mathematics of how they actually work. In fact, hashing is such a good way, these one-way functions are such a good way to store the passwords that currently many big companies use this way. Of course, there are small little details about how you hash them and what algorithms or functions you exactly use that can also affect the things. But this is generally the best possible way to store the answers, not by storing them in plain text, but hash them and then store it. So you won't have a company that releases all of these passwords like this anymore. Hopefully not, or we at Hacking Club will find out and will release a password list soon then. All right, anyways, so some popular hashing functions are MD2 or MD5 and SHA-123. Now, again, you can go and dive more into this if you are interested, but this is super interesting. So we're done, right? We're done with the hashing functions, and this is the best way possible, and companies use this all the time. So our job as hackers are done, right? We can't do anything more. Well, not really. See, do you remember the Rockyou.txt file? This had a huge list of passwords, right? It has, in fact, like this is 139 megabytes of file just storing passwords. Do you realize something that's happening? Well, while this is indeed a one-way function, while MD5 is indeed a hash function, and it is only possible to go one way easily, what you can also do is run a brute force attack. So what you can do is you can go for this string, you can look at 1, 2, 3, 4, 5, 6, 7, 8, 9, you can hash it using MD5, and you can say, and you can compare the hash for 1, 2, 3, 4, 5, 6, 7, 8, 9 with this hash. Now you don't know what this hash is, but you can of course compare both of these strings. And you find that maybe it does not match. So maybe you can go to the next password and try that out. Then you can try out Princess or 1, 2, 3, 4, 5, 6, 7, then Rockyou, or so on and so forth. And you can iterate over all of the possible passwords till you find a certain match. And in this case, indeed, in the entire 136 megabytes of file, you can indeed find one password that happens to just match the MD5 exactly. And this is how you can find out and figure out passwords. All right, so this is a quick CTF challenge we have set up. Before that, I'll look at some questions if you guys have any. All right. What if we don't know the hash function use? That is a very good question. You should go ahead and try out the hash functions, but most of them have certain properties that can figure out, and that you can look at them and tell if what kind of hash it is. So uh, what is the list? Yeah, MD2, MD5, SHA-123. All of these are certain mathematical functions, right? All of them have a certain output length, a certain way the hash is generated. So you can figure out what kind of hash it is rather quickly. Once you have figured out what kind of hash it is, the answer becomes a lot quicker. But yeah, that's a very good question to ask. Try all the standard ones. Yes, that is a good idea. Bribe the employees. Again, a very good idea. You can do that. But of course, for legal reasons, that is a joke. Is hashing an example of P versus NP millennium problem? I am not that into competitive programming, so I can't say about that part. All right, anyway, so this is the CTF we have set up. Can some organization create their own hash function? You can, and usually you can also publish a research paper saying that we've devised a cool new hash function that you can use. So then why do companies use popular function? All right. Uh, yeah, there is no other way, right? How can you hash? The one way is to figure out and like mathematically find a good hash function yourself, which can be a lot of time and energy and resources. And sorry, wait. Uh, wait, what is the question? Yeah. So yeah, companies use popular hash functions because there is no other way. Either they create and spend some resources and energy creating their own hash functions, or they can just use the pre-built ones. Even if we find the PS, how can we know what it is? What? Is brute force the only way to reverse hashing? Yes, it is. Unfortunately, yes. Can someone share the link in the PPT? Yes, we will do that. Would any org want to make their hash function public? That is a good question. They should not. But it happens that you can find the hashes quickly. If you have access to the hash, then everything is super easy. You just have to run a brute force attack. But if you look at the Rockyou example, the first step was to actually, let me show you. The first step was to actually find the SQL injection vulnerability. So it wasn't exactly like you weren't handed the password hashes to you, or in this case, the plain text passwords, but the hackers had to go through one step of SQL injection before they got to the database, which was unencrypted. Now, in this case, had happened to be unencrypted, but companies will usually now encrypt their databases as well. All right. Like they can also use multiple functions, right? Multiple. Yes, yes, yes. That is what they use. Yes, that is a good thought. Uh, okay, cool. I like the discussion that's happening. All right, so I'm going to go back to the CTF link. All right, so I'll leave the screen at this point. And this is just some little bit of story before you can go to the website and try and see what you can find out. Also, just a quick note, we'll pause for around 20-30 minutes. So feel free to take your time, explore the CTF challenge well. It is not exactly super easy, and there's a little bit of work that needs to be done. Anyways, I hope you guys can figure it out yourselves. Google it if you don't know it. And also, please don't put answers on the chat. It ruins the fun for the other people. So if you can figure it out yourself, drop a mail and we'll write down the mail on the chat, and you can mail it to us as soon as you get it. So the earlier you do, the better it is. Don't write answers on the chat. Okay, cool. So can you go back to the slide? Which slide do you want? The story one or the summary one? I'll keep it as summary one. The links to uh, the ID and the links will be present in the chat. Can you kindly show the email ID? Yes, story. Okay, you want story. Fine, let's go.
Hello. Yeah, so I am getting a few mails, but you guys are sending just passwords for one or two of the challenges, right? Try solving all of them and send a single mail with whatever you solved instead of sending one mail for each password that you solve.
Also, those passwords need to be either decoded or like cracked before you submit them. So it's great you have found those some things, but you need to crack those before you submit.
Yeah, so out of the passwords that you sent, most of you have found out all the hidden text, but you haven't attempted to decrypt it or decode it. You can find out. You can just Google up stuff. Most of it was in this presentation that we made. Also, feel free to discuss in the Discord server. It's much lighter text there than on Teams. Yeah, we will show you how to find out every single password and the encryption techniques or hashes used for each one of them at the end. I think at about 7:45. So don't worry about it.
I wanted to know something.
Yeah,
I just wanted to know that will the Discord server be active during the meeting as well?
the meeting as in right now.
Yes.
Yeah, it is. There are a lot of people. You can discuss with your own batchmates in the Hacking Club server.
Okay. In which channel?
In general, or should we make a new channel for it?
No, we'll discuss it in general only.
Yeah, cool.
Actually, I'm a bit new to Discord. That's why I have a bit problem.
All right, all right. I'm so clueless. That's fine. You can look at the summary right now. You can see the encodings and hash functions that we've discussed. You can just try Googling about them. Maybe there are converters available online that can convert to and from maybe base 16, 32, 64, whatever. You can just try inputting all the strings onto those converters. Do we need to decrypt the hashes and send? Yeah, you need to decrypt the hashes and send. Yes. Only able to dehash one of them. That's good. That's great. Keep trying. You have a lot of time. Yeah, you gotta send a mail after you decrypt all, or however much you can. Doesn't have to be all, but yeah. Just don't keep sending a mail for each one that you decrypt. It becomes hard to keep track of who sent which. It'll take forever to rehash them with it, considering we have checked that this challenge is definitely solvable without using any tools or any external code. It is definitely possible to solve it within 10 minutes, maybe. Keep trying. The challenges are on the website. I think we should post that link again.
Are all the different passwords encrypted in different ways?
Yeah, each password you come across is encrypted or encoded in using a different algorithm.
Okay, thank you.
Okay, so it's been 15 minutes, and I think most of you have by now visited the page at least and found out how to look at the encrypted passwords. I'll give you a hint. The description of each user gives a hint about what kind of encryption is used. So maybe that might help. Okay, I see that people are saying they're clueless or they got stuck on something. It's fine. Just try another password technique maybe. It's fine if you're clueless, we'll tell you what exactly to do. So don't get discouraged. How to decrypt the password? Can you recommend a site? Try Googling. Google for whatever encoding techniques. These are what you suspect may be there. And I'm pretty sure you can find converters online. You can use them.
Right. Hello. Am I audible?
Yeah.
Okay, cool. So we'll get started with the solution. And cool. Yeah. Uh, all right, fine. So one thing I want to say before we get started with, actually, I'll walk you through every single step. You don't worry about that. But I want to say one thing before. When I was in my first year, I actually got scared that other people were able to solve everything, and I was not able to solve any single thing. So don't be scared. It's not about you figuring out or you having that extra knowledge to get you through all of this challenge. If you can solve all of it, that's great. That's super. But if you don't know, well, you can always learn. And that's the one thing about hacking. You never stop learning. Every day something new comes up and it's always amazing. All right, with that being said, let's get actually started with the walkthrough of how to actually get all of the passwords. So the first thing we'll note is that there are a couple of things going on. Okay, that's a cool background we have. Connection is monetizable and so are you, that's fine. So usually in these websites, we want to look at what all links they provide right away. So we see one which is beta, which is, well, it looks like the Meta logo just flipped around. That's fine. So this is just the homepage. Then this is also the homepage, which is just a different URL. All right. So what all can we see? We also have this our employees link. So that is something to check out always. Okay, it looks like we have something written over here which says remove email IDs and passwords before publishing the page. Okay, so this looks like since this website is still under construction, some of the developers may have left something behind and they've written a note to self saying that email IDs and passwords should be removed before publishing the page, which means that there are email IDs and passwords over here. So we see, all right. The first person looks like Mark Zuckerberg. Don't worry, you'll see the part 2 of this CTF very soon as well. You'll actually meet Mark Zuckerberg that. Anyways, okay, so we see that there are a bunch of email IDs and passwords, but what you can do is you can try copying this and you can go ahead and paste this in another search. So it looks like we can indeed find out the website and copy paste. But if you copy the password, if you go ahead and copy the password, it won't show you. It won't let you copy the password. And you can go ahead and try and printing this out again. It won't show anything, which means that, you know what, this is the password. Yes, I'm looking at the password, but it is not showing me what it wants. It's not showing me what I want. So I'm going to get what I want. And how do we do that? Well, one of the things that you should know, and this is super important, is that when you right click, you will get the option, and there are a couple of options here, but one of the most important ones is view page source, and the other one is inspect. So what view page source does is it will extract out and will print out all of the data that the website used to generate this. So it uses something called hypertext markup language. This is just a language to show and tell how these web pages are being shown to the public, right? So this is just the source code of the website. All right, so now we want to start looking for some things that are interesting, something that is just obvious or maybe something that looks different. So we'll go over them one by one. We'll see. Okay, we have a couple of titles. It looks like ranks. Maybe these are interesting, maybe these are not, right? When you're looking at this website for the first time, it is okay to not know what is the interesting part, but the more experience you gain, the better you become and the more you're able to see these things. So we'll go ahead and scroll. Okay, this is the note to self that we saw before. So this is present over here. All right, that's fine. So we'll still scroll and it looks like we're done. There is nothing more in the web page. So what do we do? Well, it also looks like there's this script present over here. If you see, there's this script.js file. So I'm going to go ahead and click this and we'll see where it takes me. All right, so here we see that we have a user list. All right. And it says image random user. That's fine. It says Chris lol as the first and last names.
Tanishq, I think your stream is lagging a bit.
All right, so I'll go slow.
Yeah, sure.
Okay, fine. All right, so what do we see over here? It looks to be the user list and the first and the last names look fairly familiar, right? Chris and lol and was the person present over here. And then we have Charlie and Put, and this is the guy over here. So which means that we have indeed found out the list of all of the users, which means that now we have access to their emails as well as passwords. This is, remember, something we could not see before. So now we have the access to the passwords, which means that we can start to do something with it. But what do? Well, we can go ahead and look at the first password, which is just a rickroll. So as a hacker, the first thing you should know is how to avoid rickrolls at all costs. So feel free to go ahead and click on this link if you want, but I'm going to ignore that for now. All right, so we see that this is the encoded string we provided to us. I'm going to copy this and keep this in the clipboard. And it says wannabe hacker. And if you look at this string closely, you'll realize that, OK, there are two equals to sign at the end. And what this hints is, as I mentioned in the slides before, hackers commonly use base64 encoding a lot. They use it a lot. So what we're going to do is we're going to look for, we're going to go and search for base64 decoder, right? I'm not going to do anything special. I'm just going to Google it. And I'm going to show you exactly the steps we took to solve this ourselves. So what do we know? Well, it looks like this is a wannabe hacker, which means that it probably hints at base64. And so I'm just going to Google base64 decoder. Okay, it looks like there's a website called base64 decode. Right, hacker encoding. Oh, okay, that's good. All right, fine. So we're going to just put it over here and decode. And if you decode, you will get a nice little string saying here in Hacking Club, we strive to use our resources to get whatever we desire. You may know your way around your PC, but are you using it to their full potential? This, by the way, is one of the passwords that we kept, so you could go ahead and submit that as well. But we'll move on to the next one. So we already found the passwords for Charlie Put. Now, what about Cortana? Well, Cortana says that she is a Bitcoin enthusiast, and we have this long string provided. So what could it possibly mean? Well, let me just search for Bitcoin address or Bitcoin encoding. How about that? Yeah. So when I Google for Bitcoin encoding, I get something called base 58 check, or 58 characters base 58 number system. So this is something we did not tell you explicitly, right? I only talked about base 16, 32, or 64. But if you look at it closely, just by Googling this, you were able to find something different. You were able to find base 58. So let me go ahead and search for base 58, decoder. And we'll just go for this first website that comes up. We'll put it over here. So let's decrypt this and we get this. These encodings that you're cracking are used everywhere. For instance, base 58 is common in cryptocurrencies. As we already saw, Bitcoin encoding used this one. However, in order to properly use this, you must understand how they work, right? Okay, great. Is Cortana pun of court? Yes, that is a pun intended. All right, anyways, we'll move on to Pablo. All right, so it says Charlie's half brother. Now, if you recall, Charlie already was the wannabe hacker, which had the base 64 with him, right? This string was base 64, which means that since Pablo is Charlie's half brother, we're probably looking at base 32. All right, so I'm going to go ahead and search for base 32 decoder. Cool, so we get a website. All right, I'm going to copy paste Charlie's half brother, guys. So this is the one. I'm going to put it over here and voila, we get by now. You should have realized that encoding is not a good way of hiding data. Anyone can easily crack it. Let's move on to something better. All right, so I'm going to close this and we have two more users left. One is Richard A and James Oliver. All right. So Richard says he's always on crack and the James guy has hashtag Twitter, hashtag added. And this is basically a joke around, how we used hash cracking to get these passwords. So again, I'm again not doing anything special. If you look at the summary, I already mentioned this hash cracking keyword. Okay, it says lag. It should be working. Yeah, that's fine. Okay, I'll slow down a bit more. Okay, cool. So I already hinted at hash cracking, so I'm not going to do anything special. Just search for hash cracking online. Okay, nothing special. This is the first link we get, so I'm just going to go over there. All right, so let's go ahead and copy paste the hashes. The first hash is for Richard E and copy here, paste here. Second one is for James Oliver and we'll put it over here. All right, I am not a robot. Yes, thank you. Crack the hashes. And there you go. You get the last two passwords, password 321 and lover boy. And with both of these, you have indeed found out the answers for all of them. And yeah, this is it for this CTF challenge. So again, just to mention, we did nothing special, okay? We just looked at the hints provided to us. Yeah, I didn't even think about the descriptions. Yes. See, you will realize that even in real world scenarios, okay, again, for legal reasons, I'll say that, please don't try it out on actual websites. But if you look at the source code of websites, you will often find something interesting hidden over here. For example, in this case, we found a script.js file, which looked interesting. It looked a bit out of place. And that sort of intuition is something you build as an hacker over the time. So the more you look at websites, the more you hack, the more quickly you realize what is off, what is something interesting. And just by looking at that, just by looking at the descriptions, we were able to figure out what kind of encodings or decodings were there and what kind of hashes were there. Again, I did not use anything special other than a quick Google searches. That's right. Just a quick Google search can get you all the answers you need. All right, so yeah, this is pretty much it for this CTF challenge. In case you did not figure out the answers for the what is this one, I'll also quickly go over this one. So this quick little joke about not and see, and this looks to be an inspect. So again, this is just a joke about how you should always go and look at the page source. And this is where you can also get the Discord links as well as Facebook links. All right, anyways, yeah, this is pretty much it. So if you guys enjoyed this, we have one more challenge. We have one more challenge for you. All right. So you can read it and we'll quickly release the second version. And this time you have to go for a much harder challenge. This is going to be super fun. You'll learn a lot about encryption and about how basics of these things work. And this is the statement, and we'll upload you on we'll update the website. So you have the next challenge coming up soon. All right, we'll put this as well as every single resource out there on the Discord server, so you can go and look at that. Okay, let me look at some questions. So how can we get the source code on Safari? I have not really used Safari, but you should be able to right click and figure this out. But yes, step one is installing Firefox. Yeah, that's good. How do we access the challenge? Discord. Okay, so the next challenge is just the continuation of this one. You'll use the same website. This is the, sorry, which one is this? Yeah, you'll use the same beta website, and we'll add one more link over here, and now you already hacked all of the employees. Now you have to hack the CEO of this website. All right. So why is the name 0x1337? It's called HexLeet, and you should definitely Google this. It's a very nice thing. Okay, what more? It was taking too long for decryption of websites, so I just looked at common hashes and the straight of match. Yeah, that's a very smart thing to do. 1337 because leet. Yes, smart. When is the other challenge? Vishwa will update you as he adds this one more page. We'll
just hold on for a minute. I'll just show it.
Okay. You want me to unshare my screen?
No, just keep sharing your screen.
Okay, fine. I'll see what the other questions are. How many different types of hashes are there? There are lots of different kinds of hashes. In fact, we are now excited for more challenges. That's good to hear. So let me go for hashcat examples. Yeah. You have a doubt?
So I wanted to know, like, I had also joined the Discord server right now. In general, so like all these challenges and the updates, will we get them on the Discord server or on our mails?
Sorry, what are you asking for?
So basically, if you are holding an event like you did today, or this type of fun activity. So the updates for them, do we get them on our mail or on our Discord servers?
We'll keep you very regularly updated on the Discord server. You can find everything on the Discord as well as the Facebook. Those two are our main servers. And we'll keep you updated. Don't worry about that part. We're more than happy to bring you these challenges. We love this sort of thing, and we love the participation.
Actually, the thing was today we were given introduction for many clubs, and like we were told to join all their servers. So it's kind of hard to keep up updated with all of them because you have so many servers and so many channels for them.
Oh yeah, that I understand. So gradually you will also realize what your interests are, and we at Hacking Club we want to help you build your hacking interests. So gradually you'll realize what all you are interested in, and you can go and focus on that more. So it will sort out eventually. Don't worry about that part. I know it's you guys are new, so it looks overwhelming, but it will sort out itself. Don't worry about that. Okay, someone. Okay, yeah, that's good. Okay, someone asked what all different types of hashes there are. So there are a lot of types of hashes. Different softwares will use different kinds of hashes as well. And there's a whole lot of variety. In fact, I can link you this website and you can just keep on scrolling, and it won't stop. So again, don't be scared by it. It's just to demonstrate that there is a lot of things. There are a lot of things available. That's okay. Okay. So any more questions? Yeah.
So there's base 64, 32, 16, and you also introduced 58. So what are they called in general, and how many different types are there?
Okay, so I don't think so. That's an easy question to answer. Base 64 is the most common one, which you will see, and hackers generally prefer that, but base 32 and 16 are a lot less common. In any case, that is sort of the intuition you build as an hacker over time. Because even I didn't know in my first year that we had like base 64 and base 58 and all of this sort. But as I gradually learned more about stuff, like I did not know about the Bitcoin wallet thing, about how it has base 58. But over time, as I got to know about these technologies, I got to learn about these encoding. So again, don't worry about that part. There's a lot to learn, but always keep on Googling, keep on asking these questions. Google, find, it's amazing. Sometimes I go in rabbit holes, like just clicking on links again and again, just to, understand the basics of these technologies. It's always amazing. All right. So any more questions?
Yeah, I have another question too. So base 64 that is there, how is it different from the other base things?
Okay. So what base 64 means? Okay, so I don't have anything to show. Wait, I'll write down and explain it to you. It's a very simple idea, but it's good that you're asking questions. I like that. Let me show. Give me a second. All right, so there are many different types of bases. So what we commonly refer to is like this 1, 2, 3, 4, blah, 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 up till 10, and then 11, 12, 13, 14. If you notice right away, we're using the base 10 system, which is basically after every 10 elements, there's some sort of that pattern that repeats again and again. When we talk about base 64 or even base 32, is just a combination of all of these numbers. Sometimes it's numbers plus letters plus some special signs like equals to and all of that. So what it basically does is, these numbers can be a bit long. And in fact, I don't know if many of you know about base 2, but base 2 is the binary system basically. So base 2, 1 in base 10 is going to be represented as 1 in base 2. But if you go for 4 in base 10, that's going to be represented as 1, 0, 0, I think. Yeah, cool. And so on and so forth. So for 16 in base 10, you'll realize that it's a bunch of more zeros and so on and so forth. So for a big number, let's say it's just a number 36, you'll have a large representation in binary because this is base 10 and this is base 2. So base 2 takes more and more number of digits in total to give the same amount of information as base 10 does. And you can compress that even more in base 32 systems. And you can compress that even more in base 64 systems. So you can add more and more information in lesser and lesser amount of space, basically. That is the part of the reason why hackers love it so much. Base 64 is just such a dense representation that it beats base 10 or base 2. Does that make sense?
Yeah, I understood it now.
Yeah.
All right.
So
Manoj,
like there's binary, hexadecimal, octal, that stuff.
Yeah, it's exactly that stuff. The base 64 is just a bigger brother version of that. Nothing too special. Yeah. All right. Yeah, Vishwa, you were saying something? Okay, I think we're out of
I think our time is up. Anyway, the second challenge is up. Can you show the slide, the problem statement for that?
I'll show. Okay, cool. So you have one more challenge that has just come up, and you can go ahead and try to solve that one. Of course, it involves some of the basic concepts we've already seen before, but yeah, we'll show the slide. Here's the slide. So this is the problem statement for you now. The second part of our CTF challenge.
We'll even send this on the Discord server and pin it maybe.
Yeah, we'll send it over there.
It's the same link. You just find a new tab on the navbar.
Yeah, just refresh the page. All right, cool. Okay, so are we done? Should I close this or was the scene now? I think we've already overshot by like 7 minutes. This is so fun.
Yeah, we've overshot by. Okay, I see that quite a lot of people still have questions. Can we just continue this conversation on Discord, because the next event is about to happen and I think everyone has to go to the Pentaprism channel.
Okay, fine. Yeah, so we can take these questions here.
On Discord under the general channel, we can discuss that.
Yeah, you can discuss in the general channel, or if you want, I can make a new channel with the slide and the link and everything pinned. And we'll even announce the winners, like the people who submitted all 6 the hashes and 5, and basically everybody who mailed in the server later today. Okay.
Yeah.
Awesome.
All right, great. Yeah. So I'll stop then. Yeah, we'll move on to Discord if you have any more questions, but the second challenge is up and running. All right, great. Thank you all for joining us. This has been very amazing. Yes, thank you for making this session amazing. Yes. All right, cool.
See you guys.
Okay, bye-bye. Thank you.